Hello, welcome to the RC Wall Vacuum channel. So today's just going to be a quick video on a progress update on this dyno, and there is starting to be light at the end of the tunnel on this project. Let's take a look at and see what's gotten done. So the majority of the fabrication is done now. I got some more machining to do, but this is going to be the general layout. I obviously got to paint the wood and get that attached down there, but this is where this keyboard and mouse going to be mounted here. This is a speed control pot for the throttle servo over there. The hydraulic fittings and hoses did not come in today, so I did not, or this weekend, so I did not get a chance to put that in there. But got some of the hydraulics in there. There's obviously the flow control here, and got the gauge to watch. So this is, when you're operating, you're basically right here. Got your screen, got your throttle pop, and you can control the flow right from that point right there. Down here is the load cell. I am going to put a guard here to don't get pinched. I got to put some kind of retainer to keep this thing from dropping down. I don't want this thing slamming up every time you run it. I debated back and forth whether I have it forcing down on the load cell straight down or to push up. I opted to go this way in hopes that it would offset some of the gravity, but you know, it's 6 of one, half dozen another. Is it going to take some horsepower out to spin this and fight the hydraulic lines versus is gravity going to put some load down on with if it's facing down with the hydraulic lines? I don't know. Have to work those kind of details out. We'll have to, since it is a load cell, we'll have to be able to calibrate it and be able to pop this out, hang a load off of here. And being a push-pull, it should be the same push as it is pull as far as calibrating it goes. So this here is going to be the speed sensing disc. I got to put a magnet in there, and I have to 3D print a holder for the Hall effect sensor. Now I'm mounting it down here on the pump shaft. Originally I was going to mount it up there on the output off the ring gear. I was getting tight in space. So that was number one reason why I didn't put it up there. Number two reason was, and most important, is I wanted to get this Hall effect sensor as far away from the ignition as I could because of electrical noise. And then number three, this is almost a 10-to-1 reduction down here in rotational speed, so it's going to make it easier for the Hall effect to pick up the signal without, missing a beat. Now, obviously, not going to be at actual engine RPM down here, so I got to take care of it in the math and software. And I am given the option to change some of the gearing up here, so I got to add in a drop-down menu in the user interface where you can go in and set what your gearing is. And then that'll automatically compensate when it does the RPM calculation. So I should be able to get engine RPM indirectly. So up here is where the throttle servos got mounted, obviously. I put it on these posters so there's a little bit of flex. So you don't have to sit there and fine tune the throttle position precisely when you're doing engines. And that way, if you're a little tight on things and the servo wants to pull a little bit more, it'll flex here and not really stress out the carburetor linkage. At least that's the plan. And like I said, back over in the operator console is where the throttle control pod is, and everything's all handled in the electronics. There's no need for a receiver in this setup. So up here at the engine mount, I got a slotted chain tensioner in there so you can keep the chain good and tight on there. And as far as mounting the engine goes, I don't know if I put the bolts in there yet. No, there's the engine mounts to this assembly plate right into the bottom, and I got these pieces of angle iron in here, or angle aluminum, and they're slotted down through here. So you mount the engine, drop it in here, and then you can slide it across and mesh the gears that way. And you can compensate for different pinion and ring gears. I kind of messed up on this ring gear here. I originally wanted, this is a 58 off of a 1.0 5T. I wanted the ability to put a 2.0 ring gear, which I think is a 62 tooth, but I'm not sure I gave myself enough space down there. But either way, it was designed gearing-wise to use a 58, so that'd probably be fine. And I got that attached to the 10mm shaft. I made this hub here. It's all keyed to fit on the shaft, and that allows you, if this thing wears out, to be able to pop that off. And it might be able to get a 62 tooth in there. I'd have to do some. I don't have a spare 62 laying around to even try, so I'm kind of shit out of luck on testing that. But like I mentioned before, these are, I think, 34,000 RPM bearings. So I should be able to handle it. I still got to pull this off, this sprocket off, and broach it because I could not find a 10-tooth sprocket that had a 10mm keyed opening. So I had to take, and this is actually a standard I had to drill out, and now I got to hopefully broach that, put a keyway in there. And like I said, I got the chain tensioner on here. Now I've been debating what to do about the mounting a tank. I think I'm just going to put a temporary thing on there to use for now, and then the end user can put their own mount on there for whatever tank they happen to have. That's probably how that's going to end up going. And the hydroxide, this is going to be the input coming out. It's just going to loop around, go back in. I'll probably have to try to somehow support the hose so it's not putting tension on the pump to interfere with torque readings. And then the output comes off of here. Well, I reverse that. The output off the pump is going to come back into here, and you just hold back the pressure right here. So this section here will be from the output of the pump to the output of this flow control will be the pressurized section. Now I didn't put a pressure relief valve in there. I've been debating on that one. I'm hoping that whoever runs this thing pays attention and does not exceed the pressures. Although I suspect that unless you're putting a really high horsepower engine in, you'll probably never be able to push it to that high of flow, to its full flow rate and full pressure at the same time. So that's about the extent of it for now. The next video I'm probably going to cover over some of the electronics. I probably will show some of the electronics assembly and what some of the ideas are behind that. It's probably going to be, I'm going to have to tuck it somewhere up in here. Have it protected as well as I can from blast of hydraulic fluid if something was to go wrong, or rain, or if it's outside, or whatever the case may be. But that will be the next video. So in the meantime, thanks for watching.